Hello everyone, the power of pi, and today we're going to be looking at the 2007 AIME II Problem 10. So let S be a set with 6 elements, and let P be the set of all subsets of S. Subsets A and B of S, not necessarily distinct, are chosen independently and at random from P. The probability that B is contained in at least one of A or S minus A is m over n to the power of r, where we're given these conditions to make sure that our fraction is in simplest form, and we want to find m plus n plus r. And we're given a note here that S minus A is the set of elements, all elements of S which are not in A. Okay, so now let's go back to our probability. So the probability that B is contained in at least one of A or S minus A is going to be the probability that B is in A. So B is contained in A, plus the probability that B is in S minus A. So, and then in the chance that B is in A and S minus A, we're double counting this for the probability that B is in A and the probability that B is in S minus A. So we'd have to subtract the probability that B is in A and S minus A once. Make that more clear. S minus A. So let's get to calculating this. So really, actually, this P is completely irrelevant. We can just rephrase this to we're choosing subsets A and B from S, and we want to know the probability that B is in S. So probability that B is in A. So this is basically what we're going to find. And another observation is that the probability that B is in A is the exact same thing as the probability that B is in S minus A. Since there's kind of like a 1-to-1 correspondence between A and S minus A, we can do exactly one operation to get from a subset A to a subset S minus A. So these probabilities will actually be equal. So now let's first calculate the probability that B is in A. So this is going to be equal to, let's say the cardinality number of elements in B is 0. Then basically A can take on any subset of S, and we can safely say that B is in A. So we have 2 to the 6 options here. Now, if the cardinality of B were to be 1, then we need to ensure that we first of all have 6 ways to select our subset B, any of the 6 elements. Let's call our S subset 1, 2, 3, 4, 5, 6. So we select an element, say 6. We can do that in 6 ways. Choose any element. So, and then it's ensured that A has to be there. And then in the remaining 6 minus 1 or 5 elements, we choose that to either be in A or not A. Let's do another example. If B is in 2, again, we choose 6 choose elements to be in A. Those are automatically going to, 6 choose 2 elements, those are going to be in B. And then we need them to automatically be in A. And then the remaining 4 elements, we choose whether it's in A or not in A in 2 to the power 4 ways. So this will go on. In general, the pattern should be pretty clear. What's happening is we are choosing K elements to be in B. Those will then be in A. And then there are 2 to 6 minus K ways to basically put more elements in A. And then we're going to be summing over from 0 to 6. And then this is rather simple, since this looks exactly like the binomial expansion 2 plus 1 to the power 6. Okay, so this is 3 to the power 6, which is 729. So we found the number of kind of pairs of subsets B and A, such that B is in A. That's 729. Again, that'll be the exact same. Let me go to a different slide. That'll be the exact same thing as B is in S minus A. So 729. And then finally, the probability that B is in A and S minus A. Since A and S minus A are disjoint, B must be the empty set, in which we then have 2 to the power 6 or 64 ways. Already has 2 to the power 6 now, ways to choose A. And then how many different ways can we pick subsets A and B? Well, there are 2 to the power 6 ways to pick A, and then 2 to the power 6 ways to pick B. So there's going to be 2 to the power 12 ways to pick these overall. So now we just need to compute this, and this is our answer. So I'll write this as 2 times 729 minus 2 power 6 over 2 power 12. This is 729 minus 2 power 5 over 2 power 11. This is going to be 697 over 2 power 11. If we have it in the correct form, so we just need sum 697, 2, and 11, and we'll get 710. And that is our answer. Hope you guys enjoyed. Please subscribe, and I'll be making new content as usual. Take care.